Hi, welcome to our new video. In this, we are going to discuss about the distroless container images. So we are going to discuss about what is distroless container images, what is the requirement of using the distroless container images, what are the advantages and how it can contribute to the better security, and at the same time it can help you in reducing the container images overall size, which will help you to create the smaller images, which will be helpful in the faster deployments across the multiple containers in the orchestration tools like Kubernetes. So let's first go through this distroless container images. So if we talk about the distroless container images, as the name suggests, it does not belong to any particular distribution, Linux distribution. To be more specific, so what this means is that this container images, known as distroless, would be containing only your application and the runtime dependencies. So they do not contain basically something like your package managers like yum or apt, or something like your shells, which are not considered to be the programs or basically the dependencies which is required by your application, thereby reducing the things which are not required by your application to run. So it consists only your application and the overall dependencies, and thus it can help you to reduce the container images size. Okay, this is why to use the distroless container images. Now, why to use distroless images? This is a particular example where if you want to introduce a much better security by because it does not contain the additional dependencies like your package manager's shell. So if there is a vulnerability like your CVs, which is a part of your package manager shells or basically a Linux distribution, that would eventually be reduced because you are no longer using them. So the way it is said is like this: distroless images is going to help you reduce the attack surface. So this is why you will find that it helps you to reduce the noise of the scanners, the various attacks which are being propagated, thus helping you to reduce the attack surface. So distroless images, they are eventually very small. So the smallest image which is available is from the HashiCorp, and it's 5 MB in size. But if you look at this distroless image, it's 2 MB in size, and so they basically claim it to be 50% much more smaller than the Alpine Linux, which is the smallest available image available as a Linux distribution. So how do you use this distroless images? So these distroless images were initially created by the Google, and they have basically created this distroless images in a way where you can actually use them along with your Docker image build tooling. What this means is that whenever you are creating the Docker images, at that time you can use it as a base Linux base for your creation of the Docker image, and then eventually you can build over it. So again, this is available to you for creating the with the Docker image and then running the containers over this distroless images. How do you verify? See, the main aspect comes from the fact that because now we are talking about a particular image, so we need to be exactly sure that it is 100% secure, and we need to verify this. So what they have done is they have actually created a public key. So what you can do is that once you use the image, and you should use a software called Cosign, and once you have installed the Cosign, you can use the distroless public key to verify any distroless image. Okay, so you can use this command basically, which will help you to verify if the image is genuine or not. So you can say cosign verify hyphen key cosign.pub. This is a publicly available key and the image name. This will help you verify if the image is the official distroless image, which should help you to uh, get the image verified, and then you should always use the verified images only. Now let's talk about the entry point, because if it's a distroless image, there will obviously be there is no distribution, so obviously there will be some changes because the shell overall is absent, so you cannot run directly the commands exactly the same way that we run in the Linux distributions like Red Hat or the Ubuntu based distribution. So if you look at the entry point, they have a small change where you are going to put the square brackets when you are defining the entry point, and this will eventually work. But if you try it, if you don't put it, then it will not work out. Okay, so after entry point comes your Docker. So now whenever you are using the distroless images, it makes sense that you use the Docker multi-stage build for reducing the size or overall size of the image. Okay, so you are going to pick up the base image for your application, and you are going to write the multi-stage Docker file in which basically one image will be used for building up, and once you have built, then you can actually copy that inside the another image. This will reduce down on your image size. So if you are using the distroless image, you need to use at least Docker 17.05 or higher than that. This is a requirement. If you don't fulfill that, then it will you will have issues using the distroless image. Now, the basic idea that we need to use here is that we will have to use the application artifact, and the artifacts which get generated after the build, we have to insert them into the distroless image so that the overall size gets reduced. This is what we known as the multi-stage build, and it can really help you to downgrade the size by removing the additional dependencies which are being added into the container images at the time of build. Okay, so here is an example for you of how we can build. So if you look at, this is a basically a Golang application, and here we are using the Golang 1.17 bullseye. This is the base image, and we are using it as a build, and we have set up the working directory inside which all the application files will be copied, and then you get the go get, which is going to get all the dependencies. Then you can build your application. Now once you have run the build, okay, then you actually use the distroless image, which is available inside the Google Container Registry. Okay, so you can use this distroless. Now, if you look here, we initially used the Golang 1.17 version bullseye. So the way that we used was that we used a distribution-based image, but once we have run the build, then we are copying it inside the distroless. So this is fine, it's going to work, and we are basically using the Debian 11 base image as our distroless image, and then we are basically copying the build, the application build inside the go bin app directory, and then we are basically running the cmd for running the application. So the process basically remains the same. The only thing here changes is that you are using a distroless image which is based on Debian 11, based Debian 11. Now, if you look at the distroless image as an operating system, so you will find that distroless images are basically based on Debian 11, the bullseye. Okay, and images are basically explicitly tagged. Whenever you are looking for them, you are going to find them, they are explicitly tagged with a version specific to them, like Debian 10, Debian 11. So specifying an image without the distribution will currently select your Debian 11 image. So if you do not specify the distribution, it will automatically select the Debian 11 for now, but that will change in future with the new version of Debian. So it can be useful to reference the distribution explicitly, which is also a good practice. So you should make it a habit to specify the version specifically to prevent the breaking of the build. So eventually what happens is, if they change this convention in future, then the builds that you have already created and the images that you have already put, they might broke in future. So better is that you specify the version when using the images. Now, what are the benefits of using the distroless container images? So see, the major benefits which distroless images claims are that it improves the container security. How does it improve the container security? Because you are removing the package manager shell, and then all the basically the CVEs, that is your vulnerabilities associated with them, also gets reduced. And it helps you to reduce the overall container size, because then you are even further reducing it down, and you are basically removing everything apart from your application dependencies. And it also reduces your compliance scope, because those when you remove these package managers, the bash, the basic commands, then you are actually reducing the surface due to which the attacks will be less. But at the same time, the compliances, what compliances does is that they look out for particular vulnerability, and they want to make sure that you have either patch for them or you are using the latest version. But if you are not having them all together, then automatically you become compliant, because those kind of attacks are not applicable to you. So again, this reduces the compliance scope. It improves the overall container performances. So again, because your application is only running, so it will require less number of resources, and thus improving you to run the container much more quickly, because the size is particularly smaller, and you are only using the libraries which are required by your application. So again, it helps you to improve the performance and use less hardware to run your resources. It's cost efficient, definitely it's cost efficient, because again, the number of resources is less, because we have even we have further scaled down the image. So why do we need Cosign? Now this is important thing to understand with the distroless container images. So first of all, you need to understand that the cosign is because we need to verify the distroless images, right? Because even if you don't verify, then there are a number of security threats, something like your type squatting attacks, or you receive malicious images. Now if you receive a malicious image and you build it as an over, put the application build or inside that those images, automatically you are already compromised. So this is not a distroless problem, this is more of a problem where you didn't verify the image itself, whether it's secure or not. So if the build process is compromised, then your users are already vulnerable, and eventually any sort of security that you are introducing, that will not work, because the security issue inside your image has already cropped in. So it can further expand in your system and making the whole system unstable, right? So this is where you need to make sure that the images are particularly uh, safe to use, and then only once you verify, then only you should use. So this is if you talk about the type squatting attacks, so it's kind of a social engineering attack, where the attackers basically publish the malicious packages to your registry with the hope of tricking the users into installing them with the similar name. So they try to put the packages of similar names with, and if you do not pay much attention to that, or you mistype, or you do not type the version, suppose, so they can actually point it out, and they trick you down in installing them. Once you install them, then automatically it's get compromised. So this is what we known as typo squatting. So they basically make the use of your typos, which might occur when you are typing down your package's name. So this type of attack can compromise your images and your container builds. Now, how do you build the application container images with Cosign and distroless images? This is important. So initially, you are going to have your source repository, and this source repository basically contains your code and which you want to build. So very first thing that you will have to verify whether the distroless container images are basically the secure or not, and this you are going to do with the help of Cosign. We already talked about this, where we said that Cosign can be used to verify the images. Now once you have verified the images with the Cosign, this becomes your first step. So to verifying the images becomes your first step from the source repository. Once you have verified, then you are going to use it for building your container images, and using the distroless verified base images. Okay, and once you have use them, you are going to scan the image. This is important again from the security perspective, that your image is fully secure. Even though it's distroless, we have verified it, but then also scanning plays an additional layer which will help you to improve the security of your images. Once you have done that, then the you can use the Cosign app container image build, and you are going to verify the image using the cosign. So this is how overall build process is going to work, okay, with the cosign. And once you have done this, the container image scanning, so how does it basically differs? So you will find that distroless images are much have lesser number of vulnerabilities, basically the CVs, as compared to the standard container images. But that does not mean that if you are using the distroless container images, you are altogether secured and there are no vulnerabilities left in your system. Then there can be vulnerabilities depending upon your files, executables, runtime. So we are going to discuss more about the security in our next video, where we are going to pick up on why the distroless is not like the complete security. Although it adds on the security, it reduces down the attack surface. That is how it helps. But then it is necessary to understand that distroless, it does not mean that if you are using a distroless container images, you are putting all the security, and now none of the security can affect you. So we are going to discuss this in our next video. Thanks for watching our video. If you like it, please do subscribe to our channel, and I will be bringing the video next. Thank you.